Sustainable desalination, green energy integration. Sustainable desalination, green energy integration. Water scarcity is a growing concern that affects millions of people around the world. With the rising global population and changing climate patterns, the demand for fresh water is increasing, while traditional water sources are becoming increasingly stressed. Desalination, the process of converting seawater into fresh water, has emerged as a crucial solution to address this challenge. However, traditional desalination methods often rely on energy-intensive processes, leading to environmental concerns and carbon emissions. The integration of green energy into desalination processes holds the key to achieving sustainable water production while mitigating the environmental impact. The desalination conundrum. Desalination has become a lifeline for regions with limited access to freshwater resources, such as arid coastal areas. Through the use of technologies like reverse osmosis and multi-phase distillation, desalination plants can produce potable water from seawater or brackish water sources. While these technologies provide a reliable source of fresh water, they come at a cost. The environmental impact of conventional desalination methods cannot be ignored. To address these issues, a paradigm shift towards sustainable desalination powered by green energy sources is imperative. Green energy integration. The integration of renewable energy sources into desalination processes offers a promising solution to make this vital process more sustainable. Green energy sources such as solar, wind, and hydroelectric power can provide the necessary energy for desalination without the associated carbon emissions. The synergy between clean energy and water production not only reduces the environmental impact of desalination but also contributes to the global shift toward a low-carbon future. Solar-powered desalination. Solar energy has emerged as a frontrunner in powering desalination plants sustainably. Solar desalination technologies harness the abundant sunlight in arid coastal regions to generate electricity for the desalination process. Photovoltaic cells convert solar energy directly into electricity, which can power reverse osmosis systems and other desalination processes. Additionally, solar thermal technologies use sunlight to heat a fluid, which then drives the desalination process. Countries like Saudi Arabia and the United Arab Emirates have embraced solar power desalination as part of their water security strategies. These nations have vast solar potential and are investing in large-scale solar projects to power desalination plants. By relying on the sun's energy, these plants are reducing their reliance on fossil fuels and making significant strides towards sustainability. Wind and hydropower integration. While solar energy is a prominent contender, wind and hydropower also play vital roles in green desalination efforts. Wind power can be harnessed through onshore and offshore wind farms to generate electricity for desalination processes. Coastal areas with consistent wind patterns can leverage this energy source to meet their freshwater demands sustainably. Hydropower, on the other hand, is a proven renewable energy source that can be integrated with desalination in specific geographical contexts. Coastal areas with access to flowing water bodies, such as rivers, can use hydropower to generate electricity for desalination. The kinetic energy of moving water is converted into electricity, making it an environmentally friendly alternative to conventional energy sources. Challenges and solutions. While the integration of green energy into desalination processes holds immense promise, it is not without challenges. One key concern is the intermittent nature of renewable energy sources. Solar power generation is dependent on sunlight, which can be inconsistent due to weather patterns, time of day, and geographical location. Similarly, wind and hydropower generation can be influenced by weather conditions. To address these challenges, energy storage solutions are critical. Advancements in battery technology are enabling the storage of excess energy generated during peak sunlight or wind conditions. The stored energy can then be utilized when renewable sources are not producing electricity, ensuring a continuous and reliable power supply for desalination processes. Innovations in desalination technology. In addition to integrating green energy sources, advancements in desalination technology itself are contributing to sustainability. Research and development efforts are focused on improving the efficiency of desalination processes, reducing energy consumption, and minimizing environmental impact. One area of innovation is the development of more efficient membrane materials for reverse osmosis. These membranes allow for greater water permeability while requiring less pressure, thereby reducing the energy needed for the process. Furthermore, forward osmosis, a process that uses a lower energy osmotic gradient, is being explored as a potential alternative to reverse osmosis. The way forward. Sustainable desalination through green energy integration presents a compelling pathway to address the water scarcity challenges of the 21st century. As the world grapples with the impacts of climate change, finding solutions that provide reliable access to fresh water without further exacerbating environmental issues is of paramount importance. Governments, industries, and research institutions must collaborate to accelerate the adoption of green energy-powered desalination. Incentives for renewable energy projects, policy frameworks that encourage sustainable practices, and investments in research and development will play crucial roles in driving this transition. Moreover, the success of sustainable desalination extends beyond technological advancements. Public awareness and education are essential to foster a global understanding of the importance of water conservation and the role of sustainable desalination in ensuring a secure water future. Communities need to be engaged in the decision-making processes to ensure that the benefits of green energy integration are felt at the local level. Conclusion. The marriage of desalination and green energy is a compelling narrative of human ingenuity and innovation. As water scarcity continues to challenge societies around the world, the integration of renewable energy sources into desalination processes offers a beacon of hope. Solar, wind, and hydropower have the potential to transform the desalination landscape, making it more sustainable, efficient, and environmentally friendly. Through collaborative efforts and a commitment to a sustainable future, we can ensure that fresh water remains accessible to all without compromising the health of our planet. Balancing economic viability and environmental responsibility.